And I think there are some solutions that make sense, that can work, but we're not there yet. I personally, in my academic work, I keep pushing really hard to figure this out right. But building it, that's a whole other ballgame. Yeah? That's, I think theoretically, we now know that it's possible, but building it and building a system that works in those parameters, that's a whole nother ballgame. Okay, so guys, let me say a few things from yesterday. It's still early, very, very early. Yeah. We don't, and it's great that you're here because it's so early. Yeah. Bitcoin itself is only 10 years old. Ethereum was the real kickoff in 2015 for what we're doing here. And in the next few weeks, we'll dig much deeper into this. It's a very immature space. All of you, most of you have had some exposure to being frozen out on Ethereum, yeah? And just waiting and sitting until the system came up to speed again. So it's like an infant, yeah? And to really fix it, it's almost like the comparison really is to fix Ethereum, get Ethereum to the next level of becoming an adult. That requires changing an engine of a car while the car is running at full speed. Do you understand? That's what they're trying to do, literally. Yeah. And it's more, yeah. Does that comparison make sense? Yeah. It's very, very hard to do that. Yeah. So the analogy really is deep learning in AI in 2000. That's where we're at right now with blockchain. Yeah. So deep learning, I mean, people are all over this since 2000. And a lot of people in law, actually, in reg tech and legal tech, they came out of deep learning AI systems. And only because they were so deeply developed. And blockchain, that's the next frontier. We don't have strong talent yet, guys. There's a lot of people who don't know what they're doing, who are all over the place, and there is no depth yet in this space at all. This is, again, super, super early. And again, as I said, cyberpunks, paranoids, and weirdos used to be in blockchain. Yeah? That's how they were dismissed. That's changed. Yeah? Substantially, and it's just begun to change. So if you're becoming a curious and open-minded developer, you'll bring a lot of value. And this is not academia, guys. A lot of the previous big tech push came out of academia. Almost always completely centralized. Yeah? It's just sort of centralized. We have this research institute with this talent pool, and they develop this, right? The tech comes out of academia. That's not how this works at all. Yeah? So here, there are no universities or institutions, and nobody offers coherent blockchain concentrations anywhere. Honestly, this course alone, I know maybe of one or two other places that think they're doing something like this, but they're more talking about it. Yeah, they're not actually looking at what coding implementations should be considered. They're conceptualizing this like lawyers do, right? So, okay. Okay, so this is mostly independent researchers, and you can get most of this online, guys. Literally, if you devote a few hours a day to this, you can make so much progress. And I know many of you already are by simply taking these courses. Yeah? You can get ready so quickly. Okay. demand far, 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 far exceeds the supply. The problem is that you have to have a sufficient knowledge base to tap into that demand. Yeah? And the way you do it is you just start producing. Start learning and producing, start talking to people. Guys, you all have to go to the Ethereum meetups. Nobody got the law right. Guys. These are all people, they're not legally trained. At the same time, I think lawyers can really add value in the system by providing a framework and helping create legal solutions in code. Then we talked about the role of the lawyer in innovation, and we distinguished 3 different stages. And the last one, of course, being technology overturning the current system and replacing it with something new. And that's when a lot of lawyers get very nervous. So we went through a lot of this. We started out with e-discovery, and I told you that a lot of what we're talking about today in law really start with e-discovery. Yeah? This idea of facilitating and using AI to help lawyers deal with this overwhelming supply of data. And then I started telling you about this as a sort of a first mixed and interdisciplinary team approaches that lawyers had to form. Yeah? What they had to do in e-discovery, guys, that's what you have to do in your careers on a much higher level. Yeah? So e-discovery, dealing with different teams and becoming a knowledge engineer that puts people together and facilitates solutions, that's what's needed. Ingenuity, creativity, and being able to interact and interface with technology. Yeah. Okay, so then we had, of course, predictive coding, changing e-discovery, quantitative legal predictions, big data analytics. So, yeah. So it really changes the way we can interoperate in society. And we've only started this. Yeah? But this idea of n equals all. It's not just, hey, let me take a small sample of the data set that you give up or you have, and based on this small sample, I'm going to run predictive analytics. I'm going to do a statistical analysis of this. What you now have is you have all the data available, n equals all. And we can now, with n equals all, even though we only use 0.5% right now, we can see correlations in society and trends in society, in business units and so forth that we could never see before. Impossible. Yeah? And so with that, things change. Every business unit. So that's the survey that we started with. Yeah? That's why these people are now all making at 83% investments in AI, because they know without AI, they can't evaluate their data. Without evaluating the data, they cannot benefit from what the data has to offer. Yeah? So it's the combination of AI and big data and blockchain that we'll talk about in a second. Okay, so what comes with it? Well, cost reductions. That's what most folks that are using it right now in businesses, and so be it Target or any other Amazon Web Services, Amazon, that's what they want. Yeah? And I think I mentioned that the predictive analytics in which Amazon is running an algorithm based on your previous purchase patterns is suggesting new products to you. I told you how much they generate revenue with that. Do you guys remember? 1/3. 1/3 of Amazon revenue, period, is generated by that algorithm.
They're winning.
Well, how do you distinguish that from
how do you distinguish the things that they suggest from what a person might have already bought or was planning to buy? You know what I'm saying? Because they're not taking the whole history of my Amazon transactions and then suggesting things to me and making me buy them that I would have never bought without.
Correct.
You know what I'm saying?
Correct. But what they do is they look at the last 10 items and then the most recent item. That creates a perspective on where you are in your life right now and what you're thinking. And so the algorithm takes all that data and makes a prediction about where you are in your life, what you're thinking, and what products may match what you're thinking. And suggests that product to you. And guess what? That suggestion is powerful enough to drive 1/3 of the revenue in that company. It's right. It's 1/3. You understand, right? Yeah. So, okay. With it come new products and services. And of course, as the algorithm suggests, it's much better decision making. Because guess what? If they know that 1/3 of their revenue is driven by that, they're continuously optimizing that, and they can already cater towards the clients reacting to that algorithm. Yeah? Okay. We talked a little bit about virtualization, the virtual law firms. I gave you some of these perspectives on law. We talked about ROS. That was, for a lot of people, was a real shocker when this came out. It's a big wake-up call. And I started teaching this 2 years ago. People were getting really scared. Yeah. Premonition, chatbots. But again, there's no reason to be scared, guys, because you can create a different and new interoperable skill set that gets you ready for this. And there are huge new opportunities coming out of it. And so there's no reason to be worried about. You should be worried if you're not innovating, given ROS and other changes that we're seeing. But if you're behind it and you're innovating and you're finding your own value proposition in this, that there's no reason to worry, because there's huge opportunity in this. So we talked about Internet of Law, all these new practice groups that folks are creating, and then now machine learning. So I want to make sure that we talk about this a little bit, because it has an effect. So if we look at this from a time series timeline perspective, so in terms of innovation networks. So let's start out with the 60s, integrated circuits. Then in the 80s, we have personal computers. Bill Gates makes his fortune. The internet years, the bubble bursts in the late 90s, early 2000s. Now we're starting to talk about smartphones. Deep learning is sort of the next, so machine intelligence is sort of the next iteration of that. And in many ways, it is coinciding with blockchain. So a lot of people in tech, they are deeply invested since 2000 or so. First on the academic side, then on the implementation side, in deep machine learning, and that was considered the cutting edge. Blockchain, I was laughed at by those guys for a long time. Yeah? They wouldn't even engage with me. Only last year, well, 18 months ago or so, they started talking to me. And I still had people who would literally walk away from me when I said certain things, because it was just too radical for them. And it was a threat to their business models, because that's all they did. They did deep learning, right? They didn't think they had to think about blockchain solutions. I think they kept telling me I'm 10 years early. Yeah? And they felt like they were it, because they were involved in it. They understood the technology. They had built around it, and I think that has changed this past year. Okay, so So what's machine learning? It's a little too simple. Yeah, so, but we can start with this. So algorithms that allow computers to learn. And we're typically distinguishing unsupervised learning and supervised learning. And then data mining, we're defining as machine learning in large databases. So you're just feeding the machine the large database, and letting the machine recognize patterns. And that alone is super powerful with in various application layers. And then it's really about pattern recognition, speech recognition, face recognition, etc., etc. You can throw this at a lot. Once you've set it up, all it takes is a new training data set and a few tweets. I'm oversimplifying this a little. Okay, so, but the reason why we as lawyers should care about this is because we're now getting to the cognitive domain. So let's define it: knowledge, comprehension, application, analysis, and synthesis, guys. What do you do as lawyers in your first year of law school? Huh? Remember that? First year? Case synthesis? Prep the case for class and synthesize? Yeah, remember that? Okay. So there's a chance the machine can do that. Yeah? Okay. So here's top 8 applications based on machine learning. Those are the ones that you see most often now, if you want, in the public media, the papers. People get very excited. So search engines, of course, driverless cars, voice recognition, product recommended systems of web shops, spam filtering, handwriting recognition, machine vision, and face recognition. So face recognition is a lot of buzz now. And those systems are already operational around the world. China is infamous for this. They have it everywhere now. And then natural language into data. This is something that lawyers need to care about, guys. We are the heroes, the epitome of natural language processing, understanding, explaining, litigating. That's what we do. There's nobody better than a lawyer to deal with language, and to refine it and help people understand. But we can now translate this into data. So we're calling it robust parsing, optical character recognition, voice recognition, that includes speech synthesis, sign language recognition, and side channels. Okay, so the way this works is you have a huge data set that you present to the algorithm, and the algorithm translates this into a model, or gets it, I'll break this down in a sec, gets this ready for model analysis. Yeah? So, has anybody worked in this before? Solantaman, you have had some exposure, right?
A little bit, yeah.
Okay, so what is a training data set? Well, it's training data in that it has to be labeled, structured data. It can't be a quote-unquote crappy data set. Yeah? It has to be data that the machine can actually read, understand, and evaluate. And I'm using human terms now. Okay? So that means you can't have messy, unstructured data. What is messy, unstructured data? Mr. Lanterman?
Unstructured data is just any data that's kind of gobbledygook. It's incapable of being parsed.
Correct. Correct. So you can't just take some output from somewhere and throw it at the machine. That won't work. Yeah. So that means, and let me back off. So to train a machine, you need a good training data set. for actual appropriate machine learning, you need that data set. The problem is that often that data set doesn't exist. So what do? We have to create it by hand often. So there are some services out there, such as Crowdflower and Amazon Mechanical Turk, that hire people in developing countries who have an internet access and who would wish to make money by using their human skills in microtask work. Has anybody heard about this before? Microtask work. So in essence, if I want to create a machine learning training data set, and I'm dependent on a high quality data set, what I do is I call up Amazon Mechanical Turk, and they will work with me in creating that training data set. The problem with this is what? The problem is that I now have people in third world countries clicking on pictures of kittens. I'm exaggerating this a little bit. Yeah? So the way this works is you are telling the audience to create a structured data set that necessitates that humans verify what parameters exist and verify that these are the parameters that go into the data set. And sometimes that can be clicking on kittens, other times it can be, I mean, the sky's the limit. Yeah?
So this is the, like, I'm not a robot clicker thing?
Correct.
Okay.
Yeah. So exactly right. So you have to identify, is this a lamppost? You say click, yes, it is a lamppost. Because the human can identify this as a lamppost. Yeah? Is this a car? Yes, this is a car. You have these two cars in a row. Yes, these are two cars in a row. Yeah? The machine can't necessarily do that. Okay. So the problem with this is that we're all humans. Some of us are drunk on the screen while clicking on kittens. Yeah? We're fallible humans. So if you want a good data set that you feed the machine, what do you have to do? Guess what? You're doing it 15 times the same data set. Just to make sure that you create high quality data sets for the machine, you have to run it 15 times, up to 10 to 15 times, to make sure that people were not drunk when they were clicking on the kitties, okay? So, and clicking on bears that are not kitties, yeah, okay, and so forth. So that's hugely wasteful, right? So there are now better ways to deal with that, and guess what? They come out of crypto. But that's not what this is about, but you can actually, with crypto, you can actually fix this problem that we currently have with creating structured labeled data sets for machine learning. Let me backtrack a little bit. So just to get this straight. So we have training data set that is fed into the machine learning algorithm, and the new data that comes through a classifier through the same algorithm then creates these predictions. Yeah? But it all depends on the quality of the training data set. Okay, so here's what it can do right now. So this is a furnace company that tried to figure out how to improve their servicing of furnaces. Yeah? So they're selling these furnaces to homeowners, and they need to figure out ways to optimize the internal maintenance schedules, replacement schedules, and so forth. Yeah? So they wanted a predictive model based on a good training data set by which they could understand which part of the population of furnaces they had out there would fail at what rate, at what time, or had to be replaced at what time in order to or repaired in order to maintain longevity for the respective product. Yeah, that's what they wanted to understand. And so what the algorithm really did for them is it created this prediction in which, in yellow, you see the wearing in. And it's not perfect, but it's pretty good, if you see the lines here. The working smoothly is in blue, and then the need replacement is, for those in red, you can immediately say, okay, we are targeting our resources at those that need maintenance immediately. Yeah? So this is just one practical application of this. And you can actually, now there are some companies that simply by taking photos of furnaces, not feeding them analytical structured labeled data, just by taking the photos, they can create the same thing. So there's an angle by which they're, and I know the company, they have this down to over 95% accuracy, just based on the photo. Because apparently there's some changes in these furnaces that are all the same, and the photo shows it. So they can run these predictive analytics based on the photo alone. It's amazing. So the idea is that you have the training data, you're using it for training purposes, you're creating the model, and then you evaluate the model, meaning what model works the best. That was this. Yeah? When you figure out from there to there, you can actually create a whole model for all three populations. Okay, so this goes back to Mr. Christian's question. Couldn't we just use another AI to fix this? So we distinguish between supervised, unsupervised, and reinforcement machine learning. The highest iteration in many ways is reinforcement machine learning. Yeah? But we also have unsupervised and then, of course, supervised machine learning. Which one of these is currently the state of the art that works?
Supervised?
That's right. That's why we need people clicking on kittens. Yeah. Because the unsupervised and the reinforcement, they have had applications in some in some capacities, but they don't provide the outputs and solutions that we actually need at this point. Yeah. They're still experimental. Some people will critique me for this and say I'm okay. But state of the art is supervised machine learning. For that, we need the training data sets, no way around it at this point. Yeah. And crypto can actually help that. We can actually optimize what Crowdflower and Mechanical Turk are doing, Amazon Mechanical Turk are doing. You can optimize that with crypto technology. At a minimum, you can cut out transaction costs by facilitating these services to microtask workers in Amazon Mechanical Turk and Crowdflower, and saving fees. Yeah, that's at a minimum what you can do. There are other things that you can do with this, but through crypto you can actually help optimize AI at a minimum by cutting costs. Okay, these go all in parallel. There are people working only in this, and in this. Yeah? Over time, the more the supervised models evolve, the more training data sets there are, the more applications we see. Sooner or later, these others will get optimized, but until we get there, they in some ways still work in silos. Yeah? And now they're all machine learning, modes and applications of machine learning. So, okay, so, oh geez, okay, I need to get through this. We haven't even started with, yeah, this is important for you guys, because this is about your role as lawyers. So, who are, and you can tell this is not a decentralized perspective on future skill sets. So, because this shows a pyramid structure, yeah, it's a very centralized way of thinking. So, the ML researchers that create these algorithms, they're really at the top of the food chain, if you want. Yeah? They typically are academics, Ph.D. level researchers who are writing these academic papers about this. Yeah? At some of the leading centralized institutions, including the names that we all know. So they're not the ones that you need to interact with as lawyers. Lawyers have to deal with the folks at the ML engineering level and data engineering level that actually implement these solutions. Yeah? And we haven't even started talking about blockchain at this point. Yeah? So you need to be able to talk to these machine learning engineers who are now creating solutions based on the underlying research that the researchers have provided and are implementing those. Yeah? And you need to be able to talk to the engineers because they work with your clients. Your clients will want, as with the furnace example that I gave you, let's say you work as a lawyer in a capacity to assist a furnace company, and they have started hiring these machine learning folks, and you need to figure out new legal solutions in conjunction with the machine learning team. You need to be able to understand what they're talking about. Yeah. That's all I'm trying to point out. Okay, now let's see. I'm going to get to this pretty quickly. Blockchain technology. Okay, so let's do the blockchain technology run through. We all know the definition that Vitalik Buterin gave us. Let's be clear, we wouldn't be where we are today without him. We should want for him to succeed. But he has to address those issues. And he probably has to step down from his role. Because there are too many people who will follow him no matter what. Like lemmings. If Vitalik says it, and let's face it, he acts like a central bank. When he thinks the system is overvalued, all of a sudden he sells $22 million worth of Ethereum. That's what a central bank does. To control pricing, yeah, that's what he did. One person acts as a central bank. No, can't have it. That's not decentralized. Yeah? Now, it's the problem of the first mover. Yes, the platform set up smart contracting, facilitated it, based on an incomplete understanding of what they can do with it in a decentralized setting. They couldn't have known, they just started building something that they couldn't have known they could grow into a fully decentralized system. Yeah? So it's the chicken and egg problem, you have to start somewhere, right? And so, and now because of that, it has all these problems. And so other developers, they can build on this and they can improve on it, but the only reason they can improve on it is because they did it first. Yeah? So it's a little bit perverse. In some ways, you want them to be around and to benefit from their achievements, but only if they fix the problem, right? But again, fixing the problem in many ways means changing a machine on a truck that runs 100 miles an hour. Yeah. Okay. So, okay, we've been through this. You guys are all somewhere here already on the green line. Yeah? You start appreciating, that's why hopefully while you're taking the course, you start appreciating how little you know and how much you should know. Yeah? And so at the end of the course, very likely that's going to be worse for you because you're knowing a lot more of what you should know. Yeah? Okay. And then blockchain, you all know it's a shared ledger, cryptography is involved. We have a consensus algorithm and shared contracting. So here's some buzzwords that people like to use in this space, and I've done that in the past. I'm a little less inclined to do so now because there's some abuse with some of those terms. So embedding trust rules inside transactions, timestamping, identity ownership, resistance to censorship, creating a cryptocurrency market, self-execution of business logic with self-enforcement, running decentralized services. All of this is possible on the blockchain. This is just what it can enable. What you build on the green items is almost limitless because of its Turing completeness. And maybe people will say that's hyperbolic. Maybe it is, but I've been. Yeah. So, so it's a meta technology. It's a decentralized database, decentralized computers in peer-to-peer networks, and that's really important, guys. It really is the foundation of a peer-to-peer economy, all the way, without the need for intermediation by centralized systems, which is how we run society today. Everything we do is intermediation. Everything. We always pay somebody to render services for things we cannot do ourselves with a counterparty, either because we don't know the counterparty or we can't interact with the counterparty. So what it does is it re-engineers things, and that's why people get scared, because they don't like that idea. People like to know how things have been done in the past, and now they will hopefully function in the future. Well, we're re-engineering right now. And there is this intermediation, but arguably at the same time, some people say it actually creates a new form of intermediation. This is Christian Catalini at MIT at a recent conference said that. And I got up and I asked him what he was saying, why he was saying that. He didn't quite flesh it out, but I guess the argument here is that as we are re-engineering processes through the technology, the way the new processes turn out can also create new intermediation needs. I guess that's the argument, which means jobs. At the same time, the ultimate objective is to not have those intermediary steps. So maybe that's just one or two steps removed. As we're re-engineering processes in business structures and in society, if you want, the re-engineering creates new intermediation needs, but ultimately that's just another step removed to get to a fully decentralized, disintermediated solution. Does that make sense? Yeah. And that's how I started this session, is it's really still super, super early for all of this. Okay. If I do something on Facebook, can that be traced? Absolutely. If I engage in a transaction on eBay, can that be traced? Absolutely. There's always a server somewhere, centralized, where the data is. Or a couple of servers somewhere where the data is. That's not the case on the blockchain. The database is a decentralized network database, completely decentralized, where every single node has a partial copy of the blockchain. And only together do they create the consensus for purposes of deciding what should be on that blockchain. That's a crucial difference to what centralized server systems do for society. Guys, you can control this. Just because of the way it works, you cannot control this. Now you might say, well, what about data mining farms and government oversight over mining. So if we have a mining whale somewhere in Iceland, doesn't the government in Iceland have control over what the whale does? Yes, it does. But at the same time, if they shut that whale down, somebody else, somewhere else, will pop up pretty quickly and fulfill and step into the role of that whale. It will take a while, but there is that possibility. Yeah? So, control, yes. Control, not really. Yeah. Okay. So, in that, the whole debate, guys, led by governments and government authority, is about what can we do to preserve our own role in the future of the crypto evolution. They don't always say it that way. They make these provocative statements. Oh, we're thinking about banning it. The Dutch finance minister the other day came out with it. I'm now being invited by lobbyist groups to support European legislation against the European Commission proposal to shut it down. The European Commission has put something together to shut down crypto trading, period. Use of the technology, period. Not shut down, but create substantial limitations. They're now calling me up and saying, we want you to get on this ad hoc committee to draft a counter proposal to the Commission proposal. Because they want, so. What happens if the Commission proposal, which substantially limits the use of the technology and limits cryptocurrency use cases? What's most important for this whole government debate? And Cayman, I'm an advisor to Cayman, the offshore jurisdiction, and they are among the early movers in this, very progressive. So they start understanding what this actually means. Not fully, but they get it. What's crucial?
Well, all they care about is if they can tax it.
That's it. You just have to find a way. Now, ultimately, if we live in a decentralized society of the future, there could be an argument to say that enabling them to tax it actually limits a fully decentralized future. Because taxing means government preservation. Government preservation means centralization. Arguably. But one thing we haven't figured out, who in a decentralized future, based on this technology, can preserve human rights, can preserve criminal law obligations, can preserve dignity and so forth. Yeah? We haven't talked about that yet. So those are issues. Now, there's some perspectives on this, but those are things we haven't figured out yet. Yeah? Meaning, who has policing authority? We know that very well here. That's how America works. Yeah? We haven't figured that out for this future. Yeah? So if somebody scratches your car or slaps you in the face, who protects you? We don't know. Yeah? That's all centralized. Now, guys, I'm telling you, if you own crypto, pay your taxes. Don't mess with that, guys, honestly. Now, different governments look at it differently. In Europe, in Germany, if you hold crypto for 1 year, it's tax-free. Yeah? So if you buy ADA, whatever you're buying, and you let it sit, and it may be worthless after a year, but if you let it sit, and you don't exchange it for something else, it's tax-free. If you start messing with it, buy expires 2 years, sell one there, you know, all this good stuff. Okay. I see some people smiling who are doing it. Okay. You now deal with all this tax stuff. Again, different countries handle it in different ways. Yeah, pay your taxes. Okay. So, guys, disintermediation. Yeah, we all know. This is a block. We know all how blocks work. We all know we've done it before. Using to make a payment from A to B. Yeah, so simplified sort of display of that. To get money from A to B, we have a transaction as presented online as a block. Block is broadcast to the network, to the miners. Those in the network approve it as valid. This is the hashing. The mining systems, the mining farms around the world. Block can then be added to the chain, and the money moves from A to B. So every time you buy something on those networks, you buy Ethereum, you buy Bitcoin, it goes through these channels. Yeah? And the delays we see are typically either because of this or because of the network being overburdened. Okay, immutability. Remember, each block has the entirety of the previous block hashed onto itself. Yeah? So one is a copy on the other of the copy of the other of the copy of the other, and so forth. Right? So,
But also in theory, then you could go back and change the original block and change everyone through. If you could catch up to the blockchain, then you would have changed it, right?
if you can go back to the first, all the way. So if I want to change something in 74, but we're now in time at 91, what do I have to do?
Go back to 1 and change everything.
No, you have to work your way to 74 from 91. How likely is that? It's extreme. I mean, it's really hard to even define how unlikely that is. Now, I'm not saying it's 0. Yeah, I'm not doing that. I want to be very clear about this. But right now, the computing power needed for that is just, nobody has that.
I mean, this is kind of out of left field, but once like a quantum computer theoretically be able to just completely change any blockchain.
My next slide. I knew this question was coming, so I put the slide on. Guys, what's quantum computing? I'm not going to spend time on this because we're just not there. And even if we were there, they're all already quantum computing resistant ledgers. And even with the existing technologies, so Craig Calcaterra is an expert, a friend of mine in course, who's teaching here in about 4 weeks. He can walk you through more of the mathematics if you want. Even the existing hash technology is resistant to quantum computing. So I'm not worried about it at this point. Yeah. But you're correct, quantum computing can change a lot. Guess what? Look at all these quantum computing slides I have in here. Oh, we could have so much fun, but we won't. Look at this. Bits and quips. Oh, I got it all right here. And it's a shame we won't go through it. Look at this. Graphics. Oh, this is gorgeous.
Who do you present this to?
Okay. So, big achievement. Blockchain technology. Who of you thinks this is important enough to compare to the internet? Nobody. Oh, 4, 5, 6. Anybody think it's more important?
Quantum computing or blockchain?
No, blockchain. Sorry, this is blockchain. We're back to blockchain now. Sorry, I skipped over. Okay, we'll do it again. We're talking about blockchain now. Who believes that blockchain technology is as important or more important than the internet, and the invention of the internet? Okay. Who of you think it's just a bubble? Really?
I don't know. I don't think I know enough about it, but I
think until they fix the bandwidth problem, I don't think it'll work.
The what problem?
The bandwidth problem?
Yeah. Oh, okay, good. We're on the same page. Okay, so so again, guys, there are some people who are literally making the comparison to the invention of atom energy, or the first light bulb, first flight, and so forth. Yeah? I prefer this, internet. So think of it as internet 3.0, some people say 2.0. Yeah? So, and you know this. So decentralization of trust, value flow without intermediaries. Those are the key words right now that we're using in this context. And it really can be seen as encapsulating all these other technologies. The investment, who remembers what I told you about this? Where are we in terms of investment in the technology these days? So if we compare inflation-adjusted 1994 investment in the internet with today's level of investment in the United States into blockchain technology, where are we? According to some estimates, up to 10 times. Up to 10 times where we were in 1994, early years of the internet. And to me, that's a big signal. So we all know Bitcoin is just the tip of the iceberg. It's a value proposition, a value exchange mechanism, but it's really only one application of the technology. Yeah. What we really talk about in this course is anything associated with smart contracting and building solutions based on that. And that's why we study Ethereum here. So smart contracting, smart property, governance solutions, voting solutions, anything that can be tied to legal solutions. Yeah, that's what we care about here. So business cases for blockchain. Guys, the technology is Turing complete. That means any business logic can be used on the blockchain. And so everything you see here, these are just examples. That doesn't mean that's it. It's a Turing complete solution. And some people take issue with that because they cannot bring themselves to think about how would the existing infrastructure change in light of this. Okay, you've seen me talk about this before. This is in many ways sort of the crucial appreciation of what the technology does. Yeah? So centralized systems, as you see on the top left, it all goes back to one point of failure, if you want. You can call it point of failure. Meaning, if something goes wrong in the centralized hub, that shuts down, there is no more hub. There is no more interaction. Yeah? Meaning, if the taxi cab operator shuts down, the whole company shuts down. What about the present? Well, what happens if Uber shuts down with its networks?
We have Lyft.
Nice.
We have Lyft. That's one show.
Well, what happens if Uber's server in California shuts down? Well, they have a backup server somewhere, right? So we wouldn't necessarily assume that it would shut down entirely, but it could. Yeah. If Uber could shut down and you can't use the app anymore, the thing would shut down. Yeah. What happens in the blockchain future if one node dies?
Who cares?
It doesn't matter. The rest, the system is constantly operable. It doesn't matter whether nodes die. Now there's a threshold question of how many can die for it to shut down. But even if you only have a few left, there's still a network.
Well, in theory, couldn't it go down all the way to 2 nodes? I mean, enough to...
That's a network.
Right?
A to B, network, right? So, first of all, we understand that this doesn't exist yet, right? we have only established a few use cases for this at this point. Yeah, so typically when I talk about this, I use the example of the cab company in Uber. Right? So Uber is disrupting the centralized past. That's where we're right now with technology. And then in the future, in order to really connect consumers and producers, the way Uber does it, Uber charges 25% per ride, that 25% belongs to the users, the producers and the users. Yeah? So the driver and the passenger, the money belongs to them in the decentralized future. Yeah? But we're not there yet. We don't have that yet. So in a fully decentralized society, peer-to-peer society, with complete disintermediation, it won't always be fully disintermediated. That 25% belongs to those two individuals. We're not there yet. This is what we're doing right now. This is all the beginning of that. Yeah. And there's some people, there's a circle of people, and I'm part of that circle, which I'm very happy about, that are actually, and these are some academics, investors, politicians, and some others, they're actually believing in building a fully decentralized society. And so this is not something that is just theoretical, where we can talk about why this could work or couldn't work. Yeah? There are people who are actually working on this. And I'm not talking about the typical crypto crowd. Okay? The typical crypto crowd is trying to press money out of this. Okay, let's be clear. They're doing this to make money. But there are other people who are actually have these very idealistic, and they're all still making money, but they have these very idealistic notions about how to create actual improvements for society in a decentralized future. And that's what this could entail. Okay, questions so far? Okay, so we know the blockchain use cases by industries, and most industries are affected by this. You've seen me talk about this before. The quote-unquote blockchain ability of a given industry. We can start with finance on the high end, in the middle here, up to 100% blockchainable. And then, of course, the question becomes the role of the regulators and central banks. Now, Cambridge University Center for Financial Studies about 4 months ago published a study that showed, so they surveyed almost all central banks in the world, and their survey shows that over 43% of all central banks participating, that a huge proportion participating, 43% are working on Ethereum beta versions or alpha versions of testing this year. This year, these are central banks who are using the technology to experiment. Now we all know that doesn't work because it's Ethereum, but the central banks are experimenting with that. Regulators, as we've alluded to many times, in different countries, different perspectives. Mr. Evans and I are actually working on a paper that he will present at FAGRI in 2 weeks, I believe, that evaluates the regulatory responses of the top 25 ICO jurisdictions. So, I will probably assign the paper in this course as well. So we'll see if we can finish it in time. But they're huge. There's still some really significant regulatory issues with this. And of course, once we publish the papers, things change radically right afterwards. So we'll see where things go. Okay, I want to move through this a little bit quicker now. Oh, this is, Professor Vermeulen and I, we talked about this, and I didn't show you the slide last time. So, but this is the IBM study I mentioned. So we have 2017 was really the year where people woke up. This is IBM. Some people who left the company cannot suppress using the word internal bowel movement. Okay, never mind. Trailblazers, 14%. The prediction here that IBM makes is for the next 2 years, we'll see mass adoption. That includes governments. Now, that does not necessarily reflect how some regulators are talking about this right now. Yeah. Hopefully that we'll see some improvements on that end. And then, of course, after 2020, we'll see the rest of folks. So maybe it's safe to be somewhere around here. Yeah, somewhere. I was somewhere here when I started talking about this, but yeah. Okay, so let's see. There's a lot of stuff that we don't have time for, guys. I'm going to end in 5 minutes because we didn't take a second break. We're supposed to give you always a little break in between. These were the predictions on investments. This is again money involved. So let's end here.